Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I'll kindly like to request our members to go to YouTube, search Ernest Sciences and Mathematics TV channel, subscribe and engage us in the comment section, and also ring that notification bell so that we can be getting updates on various videos that we upload in sciences and mathematics. So today we're going to look at the effect of radiation on matter, and basically we're going to be biased on organic compounds. Now in our previous two videos we have talked about the effect of radiations on metals, and we said that metals are made up of a solid lattice, of course, which is going to be interacting with this specific radiation, and we looked at various characteristics that were of course being described for metals, whereby we found out that for the concept of electrical conductivity and other aspects like volume, hardness, and tensile strength, these are some of the characteristics which we are going to be, of course, affected in a sense that they are going to be increasing, whereby other aspects like density and ductility, of course, per metals were being affected in a negative way, whereby they are being decreased. So therefore, we also looked at the effect of radiation on water, and we said that water is going to be dissociated into its constituents, of course, elements, in some cases whereby they're going to result in the formation of radicals, and also in some cases they're going to result in the formation of ionic aspects like the hydronium ions and other products which we have mentioned. And in some cases there's going to be a combination of these specific constituents and form other of course, analogous products like the hydrogen peroxide, etc. So in this case, of course, we are going to look at the concept of organic compounds, and this is going to form our third bit of the discussion of the effect of radiation on matter. And of course, for organic compounds, we are going to see that they are going to assume a unique characteristic, in a sense that the chemical products or the constituents of this specific compounds are going to depend on their molecular composition and the physical state or physical properties of these specific compounds. And therefore, this is going to result in the formation of specific products depending on their bond strength. So therefore, we're going to mention in this specific discussion the aspects of bond strength of various organic bonds. And from our discussion on the concept of organic compounds, I had mentioned that organic compounds are basically compounds which are made up of carbon, and we had mentioned various classes of organic compounds ranging from a single, double, triple bonds and heteroatomic atoms, which we had of course mentioned in various aspects, whereby we can be able to give this one carbon sulfur, carbon phosphorus, and perhaps carbon nitrogen, etc. So therefore, these are going to involve various bond energies, and this is going to dictate the interaction between organic compounds and radiations in that specific respect. So therefore, I've mentioned the concept of bond strength, and we're going to see that for organic compounds, the excitation energy that is going to be involved is going to be spread out on the molecules. So suppose we have a compound like benzene. This is just a hypothetical example. This is one of the organic compounds which is of course aromatic, and there are various bonds that we can be able to describe in this specific compound, whereby we're going to have double bonds and perhaps single bonds which are going to be given as such. So in some cases we're going to see that this can be described perhaps having some of the substituents like this. I'm just giving an hypothetical example. So therefore, this is going to involve the combination of oxygen-carbon bonds and this specific case which I've mentioned. And therefore, the interaction between this radiation and of course this specific compound is going to depend on the various bond energies which are involved in this. And of course, I've listed examples of the carbon-carbon bond which is going to be involved. Perhaps from this specific carbon to this one, there's a single bond. But from this carbon to this one, we're going to have a double bond which is going to be involved. And in this particular case, we're going to have a carbon oxygen bond, which is a carbonyl carbon. And of course, we're also going to have this oxygen hydrogen bond being involved in the formation of this specific compound respectively. So in this case, this is going to form our basis of interpretation for the radiation, the effect of radiation on organic compounds. So therefore, I've mentioned that This particular radiation is going to provide excitation energy in the molecule of this specific compound, and therefore the excitation energy is going to be spread on this whole molecule, which is organic. And of course, this some of these bonds which I've mentioned, whereby the weak bonds are going to dissociate first, and they're going to produce various products like the radicals that are mentioned for water, and of course they're going to be forming other compounds apart from the radicals, perhaps the ions and other similar molecules which are mentioned for water in that specific respect. So for organic compounds, we are going to see that there is an analysis which has come up with the various bond energies, which of course which are going to be rupturing or perhaps breaking down in case of interaction with this specific radiation. For instance, we are going to see that the carbon-carbon bond is going to have a bond energy which is of course greater than or equivalent to 3.9 electron volts. And of course, we can be able to look at the carbon-carbon double bond in this specific respect. So this one can be explained in two specific instances. Of course, we said that we can be able to have a carbon-carbon double bond in cyclic compounds and aliphatic compounds respectively. So aliphatic compounds and the cyclic compounds are going to have different energies if you try to consider the bond energy. So in this case, we're going to have this one 6.4 electron volts for this specific type of a bond for carbon-carbon for aliphatic compounds. And for instance, I've mentioned the concept of a carbonyl compound, of course a carbonyl, of course, which is going to be displayed in this particular case. So we can be able to have a carbon-oxygen bond for, of course, having the bond energy of 3.7 electron volts given as such. So depending on the excitation, the level of excitation energy in this specific molecule, these bonds are going to rupture in case these specific bond energies have been overcome insofar as the radiation interaction with the organic compounds is concerned. Interaction between the two, and therefore as we go ahead, we're going to see various radiations on these organic compounds, and the negative, either the negative effects or the positive ones that we can be able to exploit for various applications in our day-to-day life. So in this case, I like to request our members to check on our description boxes for various links of other videos which perhaps are going to be related to this, or perhaps are going to complement on this specific discussion for the effect of radiation on matter. So that is it for now, guys. Bye. God bless you.